Today we are going to discuss about some of the most important concepts of IP addressing, and we will talk about how subnetting works. These are going to be, or I would say, our today's major topics that we're going to cover. And as we have seen in yesterday's session, that whenever there are computers, or I would say devices, which wants to talk with each other, okay, if there is some communication that is happening from one end to the other end, then both of these devices needs to have some sort of IP addressing configured on them. So those addresses can be like 192.168.1 dot, I would say 1, and at the other end you can have address like 192.168.1.2. But there is always some specification to this address. We call it as IP address, right? But this IP address do have certain class. This IP address is structured according to some rules. Okay, that it's important to know about the rules that we use. Makes sense. So there is kind of, I would say, ranges of IP addresses that are available, and that's what we're going to start the class with. We are going to discuss about ranges of IP addresses. So we have different classes, right? We have class A, we have class B, we have class C, we have class D, class E. These are five classes that we have, and each one has certain range. So class A starts from 0 to 127. Class B starts from 128 to 191. Class C starts from 192 to 223. Class D starts from 224 to 239. And Class E starts from 240 to 255. You get it? So if I give you any IP address, let's say 192.168.1.1.10, this is kind of an IP address, okay? And this IP address is divided into four parts. You see that? So this is kind of an IPv4 address, and this V4 address is divided into 1, 2, 3, and 4 octet, and each octet is made up of 8 bits, okay? And we call it as an octet. So an IPv4 is equal to 4 multiplied by, I would say IPv4 is equal to 4 octets. Okay, that is 4 multiplied by 8, 32 bits. So IPv4 is called as 32-bit dotted decimal address. That's what we refer to this particular address as. Makes sense to all of you? So whenever you see any kind of IPv4 address, that's always going to be a 32-bit address, and that will be divided into 4 parts. Okay. Now, in most of the cases, you will find that this class A actually starts with 1 and it ends up at 126. But that's not the case. This is basically called as usable range of IP addresses for class A. But 0 and 127 also is part of, I would say, the class A, where 0 is reserved for some default routing and some other purposes, and 127 is reserved for loopback purposes. Cool, but they do reside into class A itself. So the entire range of this class A is from 0 to 127, but the usable range is 1 to 126. Okay. However, class B and class C and class D or class E doesn't have such things. But there is one specific thing that you need to be aware about, that only class A, class B, and class C can be used by normal people, by normal public, I would say. This is publicly available to be used. And class D is reserved for multicast purposes. Okay, or I would say media and multicast purposes. And class E is reserved for future and military purposes. Makes sense? So we can only use class, I would say A, B, and C. Now, these IP addresses are reserved to an organization called INA. This INA stands for International Association for Number Assignment. Okay, this is kind of a company that holds the authority or international authority for number assignment, somewhat like that. Okay, this is an organization that holds the authority to assign any IP address that exists in the world. So what happens is there are geographical, I would say, registries that have been like located or that have been assigned by this company. For example, uh, we will go to some Apnic. Apnic is kind of a registry that exists. Okay, then you can see there are a couple of other registries as well. But for Asia, this is the registry. And let's consider that staying in India, we have multiple ISPs. Like Airtel is one of our major ISP. Geo is one of the other major internet service provider that we have. We have Idea with us. We have Vodafone with us. They do not work well, but yeah, these are kind of the ISPs that we have. Now whenever these ISPs wants to purchase any IP address, they will have to contact to the local registrar, and they can I would say request for a new purchase, and this purchase will be provided to them from I would say uh, a local registrar. And INA allocates IP addresses to registrars, and then registrar allocates these IP addresses to to the customers. That's exactly how you use. Well, there are a couple of tiers as well. Somebody just mentioned in the chat that what's tier one ISP, tier two ISP, and tier three ISP. So tier one ISPs are kind of international ISPs that have laid down their cables onto like under submarine cables or so. So what happens is whenever if you look at the network map geographically, we are situated somewhere over here. Let's say in India, this is India, and we are situated somewhere over here, and there is something called USA, and this is, let's say, Silicon Valley, where the Google's server is situated. So let's assume that Google, however, do have multiple servers geographically, but let's assume that the ISP that I'm talking about, Airtel, has its network spread over all across the India. So you can reach out to here, you can reach out this part of India, you can reach out this part of India, or this or any part of India by using this Airtel's, I would say, network. Correct? But if you want to reach out to uh, this Google server, then you need to travel through this particular path and reach out over here. Now, there is no physical connectivity of Airtel that can take your data and make it reach out to the USA. So that's why this Airtel need to tie up with its upper hierarchy ISP, so that let's say there is a vendor called AT&T, and AT&T, since the internet has started, has laid down its under submarine fiber cables into the seas, okay, into the oceans. And then by using that particular cable, Airtel will pay rent to the AT&T for carrying the data traffic, okay, and making it reach to USA to Google server, and also taking the response back and handovering that particular response on the boundary that AT&T and Airtel can connect to. So this tier 1 ISPs are called as international ISPs. Then the tier 2 ISPs are, I would say, domestic ISPs or national ISPs, and tier 3 are basically called as local ISPs. So tier 3 ISPs basically take some bandwidth from domestic ISP or national ISP, and then they kind of build their customer base and provide internet services too. That's how they are divided. Cool. Well, but coming back to the topic that we were discussing about IP addresses, and also IP addresses are provided by an organization called INA. Okay, and INA allocates these IP addresses to different, I would say, registrars, and then registrars can sell them to the customers whosoever want to get purchase a block of IP. And as we discussed yesterday, uh, in 2013, the last block of IPv4 address was purchased. So there are no IPv4 addresses available. However, we still use them, but those are different private IP addresses, or I would say purchased IP addresses. Cool. Moving further, we're coming to your point that how did this particular classes come up and so and divided. We're going to talk about that. Just hold on for a minute. Okay. So as I said that now you can take any IP address and compare it with the ranges. For example, 10.10.10.10. This is kind of an IP address. How you can compare it? Or 192.168.1.0. As you have four different octets that are connected over here, you can just take the first octet and compare it with the ranges that you have. So like 192 resides in this particular thing. So it gets class C IP address. And 10 resides onto the first network. So it's class A IP address. Just like that, you can take any IP address and you can, I would say, get to know about the class that it resides in. If I take an IP address that says 259 dot something something something, then do you have any class of this particular IP address? This IP address will be called as invalid IP address, as this doesn't sit or it crosses the limit that is 255. Makes sense. So there cannot be any IP address. So you cannot I would say exceed with the IP address that goes more than 255. Makes sense. Now, what does it means that firstly you will need to understand that how computers understand these addresses, because the dotted decimal manner in which we understand the IP addresses is good enough for our understanding, but computers do not understand it. So the first thing that we're going to learn about is how computers do understand it. Computers understand these IP addresses when they're converted into binary function. You get it? So whatever we see 192.168.32.40, let's say, this IP address cannot be understood by a computer or by any device that gets connected over internet, okay, without being converted into binary. So how do you convert an IP address binary? We divide it into four octet. That's one of the part. And then there is a master formula that you can remember all the time with you. Okay, many people do use that, and the master formula is 128, 64, 32, 16, 8, 4, 2, and 1. And what are these values? These values are nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 5, 6, and 7. 2 to the power 0 is 1, 2 to the power 2 is 2, 2 is 4, 3 is 8, 16, 32, and it goes till 2 to the power 7. And how many bits do you have? As you know, that this is divided into 4 parts and each part contains of 8 bits. So you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 bits are there in this particular formula. So you always remember this particular 8 bits, and in order to, I would say, convert 192.168 32.40. Sorry about that. You might have stopped. Yeah, I hope you can see the screen now again. So what you can do, you can just separate this 192.168.190, sorry, 192.168.32.40, and let's say that 192.168.32.40. These four addresses or these four digits needs to be converted into binary. So what you can do, is, in order to convert it into binary, you need to add or sum up some of the bits that are present in this master formula. Do you see now? Firstly, we are converting 192 into binary. So do you need to check whether there is any direct digit available in this master formula or not. Like 192 is not directly available over here, correct? So what's the next option? Next option is to figure out the numbers that can be added together and they can give you this particular I would say digit or number as an answer. So if I go ahead and say that I want to add a 128, and the addition always starts, or the addition always starts from left to right, so it will always go in this manner. Cool. So let's say that we take 128 and plus we add 64 into it, the second digit. Correct? What would be the addition? The addition will be 192. So this kind of satisfies the number that we were looking for. Makes sense? So what you need to do is whatever value you pick from this particular, I would say, master formula, you set that value to 1 and rest of the value will be 0. Simple enough. So what would be the binary for 192? That will be 1 1 0 0 0 0 0 0. That's what the binary is going to be. How would it go for 168? For 168, we can say 128 plus. Now we cannot add 64 in it, otherwise it will be 192. So let's try and add 32. 32, by adding 32, the value gets 160. It's still lesser than what we require. So can we add the next digit to it? 16. We cannot. It will cross that particular value. Can we add 8? Okay, adding 8 seems a good option. And then that kind of gives us the value. That is 168. So what are those values that we added? We added 128, 32, and 8. So 128, 32, and 8. So first, third, and fifth. That's what the bits are going to be as 1. So the binary conversion of that becomes 101010000. Easy enough. That's exactly how you basically come up with the binary value of 168. And then for 32, 32 is already mentioned over there. So you can say 00100000. That's what gonna be the binary for 32. And for 40, the addition can be 32 and 8. So these two are going to be the values that will be added together. And the binary becomes 001010000. Do you get it? That's so easy for you to convert any binary, or I would say any IP address into binary. Understand that? So that's how binary conversion is actually done. So go ahead and try converting an IP address for me on your pen and or by using your paper or notes. Say 212.153.97 dot I would say 113. Convert this particular IP address into binary for me and let me know when you're done. Okay, I'll give you 2 or 3 minutes of time. All right, so as most of you are answering the question, let's try and convert this address into binary and see if most of you are correct or not. So as we have, the first digit is 212, the second octet is 153, the third octet is 97, and the fourth octet is 113. So for 212, we'll make an addition of 128, okay? Plus we will add 64 to it. That will give us 192, okay? And then we will add the next digit as well. So if we add 32, the it will cross it. So it'll we will add 16 to it, and then adding 16 gives us a value of 208, okay? And then we need another 4 over here. That is plus 4, you can say 212. So what are the digits that we added? We added 128, 64, 16, and 4. Okay, so we say 1, 2, 4, and 6. So the binary for 212 is going to be 1101, okay, 0100. That's what the binary is going to be for 212. Then for 153, the binary is going to be 153, plus we cannot add now 64, so we will I would say if we even add 32, that becomes even more, so we will add 16 to it, then the answer becomes 144, plus we even need some more bits, so if we add 8 to it, it becomes 152, plus we can add 1 into it, and that becomes 153. So we say 128, 16, 8 and 1. So for 128, that's 1. Then for 16, we say 001. And then we again add 1 and then say 001. So it's 1001, 1001 for 153. Then for 97, we can strictly go ahead. We can ignore the bits 128 as it's bigger than 96. And we can start with 64. And if we add 32 to 64, then it becomes 96. Correct? And we just need another bit that can be 1 and it will become 97. So you can say 011000001. That's what the binary will be for 97. And for 113, we will say 96. So that's 011, plus uh, if we add 16 to it, then that's gonna get 112, plus we add 1 and that will be 113. So you can say that it's gonna be 0111 and then 0001. That's what the entire binary is for for an IP address that is 212.156.97.113. Make sense? So you can, I guess you can now convert any IP address into binary address. Okay, any given dotted decimal address into its binary form. Make sense? Now, as you understand the binary conversion, let's see that how did this classification happened? Like how did the ranges are divided into 0 to. So when we talk about class A, okay, the range comes up as 0 to 127. And if we convert, if we see the first octet that is available over there, then you can say, if we talk about the first address, you can see that the first octet has a range of 0 to 127. Now, if we consider the binary, I would say mechanism, there is a minimum combination and there is a maximum combination. If we say that the first octet has all zeros, what becomes the decimal format of this? It becomes 0, as everything is 0 there. The decimal is also going to be 0. And what happens if I just turn everything on? In the binary language, 0 means off and 1 means on. Okay, so if I say everything is off, it means that the decimal is going to be 0. And if we say that everything is going to be on, so what will we need to do? We will need to add 250. Sorry, we will need to add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. We will need to add each and every digit that is over there in the master formula. And what does that gives us? The addition is called as 255. So it will end up on 255. That's why you can see that the starting always happens at 0 and the last possible value is 255 over here. Makes sense to you? But that's not what class A is. Class A has a classification that it starts at 0 and ends up at 127. And how does it get ensured? The thing is that whenever the IP addresses were developed, then it was noted down that the first bit, the very first bit of each and every octet, or I would say the very first octet, will be reserved as 0. Okay, and cannot be modified at all. It is reserved for the purpose. And then the user can only modify the last 7 bits of the network prefix that you know about. Okay, so if we even consider the minimum combination while keeping the first zero as reserved, you can say that everything is going to be zero, and the decimal is again going to be zero again. And what would be the maximum combination? You will see 7 ones, as the first one is always going to be zero. You cannot turn that to one. And what the combination gets you as the output? It's 64 plus 32. 64, 32, 16, 8, 4, 2, 1. And the result is nothing but 127. If you add all of that up, then the result goes to something called 127. Make sense? That's how class A got came up. Okay. Then we talk about class B. What how class B came up is class B has a range of 128 to 191. And over here for minimum combination and maximum combination, the reserved bit was going to be 1 and 0. 1 and 0. Do you get it? So first 2 bits were being reserved over here. And user could turn off all the last 6 bits, or it could turn on, or I would say turn on all the last bits. Do you understand that? So when you put these values into master formula, you can see that only first bit is on. That's why I would say that 128 is where it will start. And as the maximum combination, you can see that the second bit is always going to be off, which meaning that if you consider all the values that are available into the binary, then you can see that 255 is going to be the result. And if you subtract the value that is always going to be 0, which is nothing but 64, then the answer is nothing but 191. So that's why you can see that class B is designed. Do you understand that? That's how class B is, I would say, reserved. And if we consider the information about class C, which is starts from 191 to 223, then the minimum combination that class C has and the maximum combination that class C has is first 3 bits, and those first 3 bits are always going to be 110 and 110. Makes sense? So the minimum combination becomes 0, 0, 0, 0, 0, 0, 0, 0. Sorry, 0, 0, 0, 0, 0, just 5 zeros. Okay. And the maximum combination also becomes 5 zeros. So you can, sorry, the maximum combination also becomes 11111. So you can see that the minimum combination will be addition of first 2 bits, that becomes 192, and the maximum combination is you just need to subtract the third value from the total value that you can get. So it can always be 255 minus 32, sorry, minus 32, and the answer is 223. You can see that's how the class C range came up with. Do you understand that? There is no such information on class D and class C, and it is sensitive information that is not encouraged to be taught in the classroom. So you can do your research on internet regarding class D and class E. Perfect. Yeah, we are just like focusing on smaller and smaller things. However, I know that most of you guys are answering into the chat section and pretty advanced, but I would suggest you not to provide answer, or not to, I would say, put questions. I know you, every one of you has Google with you, and everyone might be having some knowledge in advance as well. But let's just go with the flow and let me come up with each and every topic sequentially. I'm going to cover everything that I have the knowledge of. So don't worry about the concept. If I miss the concept, it means that that's gonna come up in some other class. Okay, so yeah, please have patience and do concentrate on the topic that's ongoing. So I'll appreciate that. Thank you so much. Perfect. So moving further, now you understand how you can convert it into binary, okay, and how these classes are classified. Now we also need to see that there are some prefix values that are associated with these classes. So let's say that we were talking about the ranges, and these ranges of classes were class A, B, and C. The class A has a range of 0 to 127. Class B has a range of 128 to 191. And class C has a range of 192 to 223. Good. So whenever we think about these, there is always a a prefix that is associated with these classes. And the prefixes for class A is N, H, H, and H. The prefix for class B is N, N, H, and H. And the prefix for class C is N, 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 H, where N is equal to network prefix and H is equal to host prefix. Makes sense? We'll talk about what these prefixes are. And then there is certain default subnet mask as well that is associated. So for class A, you see 255.0.0.0 as the default subnet mask. For class B, you have 255.255.0.0. And for class C, you have 255.255.255.0 as the default subnet mask that is available. Good. Now, what this prefix means? It means that let's say that there is a network, okay, called 192.168.1.0, and you are having network prefix as N, 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 and H. You are having three octets dedicated as network prefix, and you are having the last octet dedicated as host prefix. So, what users can do is users can use host prefix as kind of a roll number to be allocated for themselves as a unique ID also. So let's say that we have a network in which we have 100 people that are connected together, correct? And the IP addresses that are allocated to them in series starts at 192.168.1.1 and it goes like 1.2, 1.3, 1.4 all the way to 1.99 and 1.100. And the available range for this address, of course, is going to be the first three octets are going to be constant and it's going to be from 0 to 192.168.1.255. Make sense? So out of these ranges, we are using these 100 IP addresses over here. Now, can I say that, let's say that we assume these 100 people are sitting in a classroom, right? And there are 100, I would say, out of 255 benches that are available, we have consumed 100 benches. So, can these 100 people communicate with each other as they are part of the same network, as I understand? I hope yes, or I assume yes. Now let's take a scenario that there is a person who is having an IP address called 192.168.1.43, and this person changed its IP address from 192.168.1.43 to 192.168.1.143. Changed, will this person be able to talk with another other 99 people that are present in this particular network? Right. The answer is that yes, they will be able to talk with each other because as I told you that the range, the available network size is of this 256 IP addresses. Okay. And out of this range, we are just using 100 IP addresses over here. You understand that? And as you are just using this 100 address, the remaining addresses from 101 to 255, they are still, I would say, empty, and they are vacant. So you can say 101 to 255 are still vacant. Okay, and if anyone takes this 143 IP address from the vacant list, then he still will be able to communicate with the rest of the network. Makes sense? So, but let's say that this one fifth that the person who was carrying 192.168.1.43 address changed its IP address not to 143, but he changed the IP address now to 192.168.2.43. Now what would happen? Will he be able to communicate with the rest of the other guys? All right, almost everybody says no, 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 and that's basically the correct address. What would happen if this particular person changes his IP address to, let's say, 192.169.1.43? What happens now? Still now? Perfect. Because what this particular person is doing, as I told you, that this is going to be a class C address. And in class C, this is kind of the prefix length that you have. You have 3 octets reserved as network prefix, and you have 1 octet that is reserved for host prefix. Means that if you want to stay in the same network, then your first 3 octets needs to match with the existing network ID. Do you understand that? And you are only allowed to change the last octet from the available IP addresses. That too, you cannot just set any IP address. You cannot go ahead and say 305, correct, instead of this 43. You need to keep it into the same network by making sure that the network prefixes are same, okay, and only the host prefix are changed. Do you understand that? And that's what the thing is over here in the game of prefixes. So that's how prefixes are described. I hope you understood how prefixes works. That's pretty easy. I would say the best example I could give in order to make you understand with the prefixes. And then the subnet mask. These are basically the default subnet masks that we use. For class A, we use 255.255.2, sorry, 255.0.0.0. For class B, we use 255.255.0.0. And for class C, we use 255.255.255.0. Correct? Now, these does, I would say, specify some of the boundary limitation that how big of a subnet it can be. Okay. So you can say that the subnet mask basically defines that subnet mask is kind of a value that specifies that how big is this network going to be. So as I told you that 192.168.1.0. Whenever I specified this address, I meant that n. We are having 3 network prefixes, correct? And we talk about the last octet is going to be host prefix, meaning that we can go from 192.168.1.0 to 192.168.1.255, not 6, 255. So combining them together, you have 256 IPs, correct? So can we say that this particular thing 256 is basically the length of the network? But this length of the network is figured out by considering that what is the subnet mask that is configured on the IP along with the IP address. Without subnet mask, you cannot communicate with other hosts. Okay, so subnet mask is kind of a number, or I would say just like IP address, it is made up of 32 bits dotted decimal value. Okay, and it's again divided into 4 octets. Cool. So, and this is the default subnet mask. We are going to talk about subnetting and all soon. So you will understand why subnet mask is used and how subnet mask is changed with the information that you can play with. But by default, you just need to understand that these are the default subnet masks that are there. Now, there is one more thing that you need to understand, and the thing is called as CIDR. And CIDR stands for classless inter domain routing. Okay, we call it as CIDR, and the CIDR value is represented by slash notation. Okay, and what the CIDR is? CIDR is basically the short form of how you can represent the subnet mask. So if your subnet mask is saying 255.0.0.0, correct, it has network prefix and then it has 3 host prefix as it's dedicated for class A. And if you convert this subnet mask into binary, just like we did convert IP addresses, you will get the output as 1 2 3 4 5 6 7 8 0 0 0 0 0 0 0 0 dot 0 0 0 0 0 0 0 0 dot 0 0 0 0 0 0 0 0. So what this CIDR is? CIDR is nothing but number of bits that are present as part of the network prefix in the subnet mask. How many number of bits are present into this subnet mask that belongs to the network prefix? Can you tell me the answer? How many bits are present into this subnet mask, okay, that belongs to the network prefix? 8, correct? That's why the CIDR for class A will be /8. Make sense to you? Just like that, if we consider, I would say, class B subnet mask, then the class B subnet mask is 255.255.0.0. And if we convert this address into binary, it would look like 11111111. You understand that? So totally for class B, you have 16 bits reserved for network prefix, and you can just figure that out by just looking into the prefix value. So that's why for class B, the CIDR value is /16, and for class C, it is /24. Make sense? That's what subnetting is, or I would say that's what CIDR value is, and the default subnet masks are. Make sense? So I hope you understood how IP addressing is done, okay, and how IP addresser came up, and we would say how network prefixes are situated, and how default subnet masks are allocated, and what do we actually call as a LAN, a local area network. LAN is basically a network in which all the hosts are into a same network and they can communicate with each other. That's what we call a LAN as. Perfect. So after getting to know about the default subnet mask, let's see why do we actually need subnetting to be implemented. Let's say you are a network admin of your company and you are requested to set up 5 different networks, and in which each network should have 30 host capacity. So we can say that network A needs 30 PCs, correct? Then you say network B needs 30 PCs, network C needs 30, network D needs 30, and network E needs 30 PCs. Do you understand that? And the I would say the criteria is that none of the computer or none of the network should communicate with each other. They are completely independent networks. So you see the communication between this not possible, communication this not possible, this again not possible, and this again is not possible. Each and every network should not be able to communicate with each other. That's what the requirement is. So we need 5 networks and we need 30 hosts per network. That's what the requirement is. Now, if for first network, how would you go? You will use the first network with, let's say, 192.168.1.0, correct? For second network, you might use 192.168. You will think that let's change the network ID to 2.0. For third network, you will say let's use 192.168.3.0. And for fourth network, let's say you would say 192.168.4.0, and the fifth network you would say let's use 192.168.5.0. If you go like this, then how many IP addresses are going to be provided to you per network? This will start at 1.0 and will end up at 1.255. The second will start at 2.0 and end up at 2.255. The third one at 3.255. The fourth one at 4.255, and the fifth one as 5.255. So per network you are getting 256 IPs. Okay, over here as well 256 IP, 256 IP, 256 IPs, 256 IPs. Correct? And what's gonna happen? You are only going to use 30 IPs of each and every network. So can we say that from each and every network that we have, you are only going to use only 30 IP address out of 256 that are available. So what's going to happen? 200 nearby around 225 IP are going to be wasted. Do you understand that? And we cannot have that particular wastage in our I would say production network. That's why what we do, we kind of use a method called subnetting. And what you do with the help of subnetting, you kind of divide a major network into different chunks of smaller networks. So in order to meet our requirement, what we are going to do, we are just going to use a single network. Okay, and that single network, we are not going to go like this. The single network, I would say, will be just 192.168.1.0. This is going to be our network, and /24 is going to be the default network. Correct? That's the network that has been provided to us by our network admin. And we calculate the subnetting scheme by considering four different formulas. So the first thing that we look into is number of networks. Okay. The second thing that we look is number of hosts per network. The third thing that we look is subnet mask. And the last thing that we look is, I would say, block size. These are the four things that we gotta look into. And as we are using 192.168.1.0/24, let's also consider the master formula that we had, because that's one of the most important thing that we will need. So we had 128, 64, 32, 16, 8, 4, 2, and 1. That's what you gotta always remember. Still, our requirement is 5 networks, and per network we need 30 hosts. So what we're gonna do, we're gonna figure out the number of network, number of hosts, subnet mask, and block size per network. And as we are using /24, okay, what we are going to do, we are just gonna write the binary formula of /24 on our screen. So it's 11111, okay, and 11. This is going to be what? Network prefix. And then we will write down the host prefix at 000000000. Am I going correct? Of course not, right? We need how many ones with us? We need 24 ones with us. So you gotta notify if I'm going wrong. So that's 1111111 dot 1111111, and then 000000000. This is how the network prefix and host prefix link will look like. So N, 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 and last part is H. Do you understand that? Now, whenever we figure out the answer for number of network, the formula that we use is number of networks is equal to, I'll just take these things a bit upwards so that it doesn't collide with what I'm writing. So number of network is equal to 2 to the power number of borrowed bits. Again, number of network is equal to 2 to the power number of borrowed bits. Now you gotta also pay your attention that you see this is the prefix length that we used, correct? That was 1111111. We have 24 ones, but all these ones do belong to the network prefix over here, and this prefix over here, this belongs to the host prefix. Okay, so what is borrowed bits? Borrowed bits are basically the bits that we borrow from host prefix and convert them into one like this. Okay, but whatever ones that we have, they already belong to the network prefix, so we haven't borrowed anything yet. Make sense? If you would have did something like 111, and then this 5 still belongs to the host, and these 3 are converted into network, then these 3 would have been called as the borrowed bits. So I hope you understand what the concept of borrowed bit is. As of now, we do not have anything that has been borrowed. We are just moving ahead with slash 24. That's why we have 24 ones and we have 8 zeros. So number of borrowed bit means if there is any bits that has been borrowed from host prefix. Okay, as we do not have any, we go like 2 to the power 0, and that says 1. Again, I'm saying you that what I have did, that we just saw that slash 24 is what we're going to use. In this slash 24, how many number of network bits that we have? 24, correct? How many number of host bits do we have? 8. So we have not borrowed anything from the host prefix yet. Okay, we are just moving ahead with the default subnetting scheme. And that's why we do not have any borrowed bits over here. Do you understand this borrowed bits concept? Okay. So as of now, we only have, I would say, 24 network prefixes. That's why, as we have not borrowed anything, it means that number of network is going to be two. We will talk about when do we borrow bits. Okay. So as of now, we don't have any borrowed bits over here, and that's why the formula goes 2 to the power 0, and that is equal to 1. Make sense? And what is number of host? Number of host per network is 2 to the power number of off bits. Meaning, how many zeros do you have in your network, in your subnet mask? Okay, or in your host prefix? How many zeros do we have? 8, correct? These are the 8 zeros that we have. So we specify 2 to the power 8, and that is nothing but 120. Sorry, that is nothing but 256. So what does these values state us? It is that it gives us one network, and for that one network we have 256 hosts. Make sense? This is number of hosts per network. Okay, that's the number of hosts per network that we have. And what is going to be the subnet mask? The subnet mask is going to be the number of on bits, that is 255, 255, 255 dot the off bits. So it's going to be the combination of on bits and off bits in dotted decimal format. And what will be the block size? The block size is going to be starting at 192.168.1.0, and it's going to end up at 192.168.1.255. Makes sense? One network, and that one network has 256 IP addresses starting at 0, ending up at 255. Now there is also a fifth thing called valid hosts. What is this valid host? Valid host means that how many IP addresses can be assigned to any device that uses internet. And that is, the formula for that is number of hosts minus 2, meaning 256 minus 2, that is 254. Because whenever we fetch out the block size, the first IP address of the network is dedicated as network ID, and the last IP address is dedicated as broadcast ID. Okay, so you're always going to have the first IP reserved for network ID and the last IP address reserved for the host ID. That's why the number of available IP addresses that can be assigned to any computer is always going to be number of hosts minus 2. Do you understand it, guys? I hope you are good with figuring out how did we come up with these 5 values. Now, what we're going to do according to, I would say, the requirement that we have, that we need 5 networks, and out of these 5 networks, no, network ID and gateway is different. The last IP address reserved is 255. 256 is never used. There is no IP address called 256. So as our requirement states that we need 5 networks, and we need out of on this 5 networks, every network should have 30 hosts. So we need to figure out from the four values, that is number of networks. The second value is number of hosts. The third value is, sorry, the third value is subnet mask, and the fourth value is block size. Correct? So as we need 5 networks, the number of network is going to be what? So we need to borrow some bits now. Okay. And how many network bits do we borrow? How do you figure that out? Okay. You need to see a value in the master formula that is greater than the requirement. So can we say that the nearest value that is possible for number of network is 8? Do you all agree with that? As 5 is our requirement, can we say that 8 is the nearest value that is available over there that fits our requirement? We cannot go with 4 because 4 doesn't satisfy the requirement. So we can go with the minimum wasted value, that is 8. And where does it sit into the power of 2? The power of 2 goes with 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Do you see that? We mean that 2 to the power 3 needs to be entered over here. That means we borrow 3 bits from the host prefix, okay, and then we convert that 3 bits into network prefix, and that gives us a value of 8. Meaning that if we kind of see that the network we are going to use is 192.168.1.0, and slash 24 is the default one. If I write down the default into binary, it was 111111111. Correct? But as we had these, I would say, zeros, out of these 8 zeros that are available, okay, these 3 are going to be converted as network bits. So they are going to be changed from 0, 0, 0 to, they will be converted into 1, 1, 1. You see that? So this is part of network by default, this is part of network by default, and that's part of network by default. And then as you entirely had this as part of host, but it is again divided into 2 parts now. Okay? And the part is, this is going to be network, and this is going to be host. That's how the division is happened. And we will call these values as borrowed values. Make sense? And how many bits are there? 3. That's why we have specified 3 bits over here. And that's how you got number of network as 8. Make sense? Do you understand how did we come up with that value? I have explained it in the easiest manner possible. You need to borrow because we need to divide those values. Okay, you need to divide a large chunk of network. Earlier we had a network, one network that had 256 IPs. Now we are going to divide this one network into 8 smaller networks. Make sense? Yes. So I would say these are the number of networks that we had. Now moving ahead with number of hosts, how many number of hosts do we have? Number of hosts is 2 to the power number of bits, that is 5. So you say 2 to the power 5, that gives us 32. Do you understand that? Meaning that we are going to have 8 networks and each network will have 32 hosts per network. Do you understand that? Earlier, when we didn't borrow anything, what was here was everything was dedicated for hosts. And that resulted into 2 to the power 0 as number of network with one network, and 2 to the power 8 as number of hosts as 256 hosts. Correct? But now over here we have divided it, okay, into three, I would say 8 different parts. So if we say 256 divided by 8, that becomes 32. So we'll get 32 hosts per network. Make sense? And just for that, the subnet mask now will be changed to something like, so 255.255.255 will be the constant that equals 8 bits, 8 bits, and 8 bits. How many bits do we need now? How many bits do we have in our subnet mask? 27. So for the last 3 bits, you need to put these 3 bits into the master formula that we have, and you need to add them up. So this is 1, 1, and 1. And rest of these are now still 0 according to this rule. Make sense? Okay, that's a question. It says, in this case, where the number of hosts required is more than hosts available, what do you do? Then you switch the class. You go into class B or you go into class A according to the requirement. Cool. Yes, I will again explain you how the subnet mask came up. So do you understand that how did we come up with this 3 borrowed bits? Perfect. And what we are going to write down in the field of the subnet mask is nothing but the dotted decimal conversion of the subnet mask that has 27 ones. That has 27 ones. Okay. And these 27 ones are came up. So if I consider the master formula, which is 128, 64, 32, 16, 8, 4, 2, and 1. This is nothing but 1, 1, 1, 1, 1, 1, 1, 1. If I come up with the addition of everything, it is nothing but 255 for the first 8 bits, 255 for the second, and 255 for the third one. Do you understand that? And then for the last octet, we just have first 3 bits as on. So that's why we will just sum up 1, 2, and 3 over here. And we will leave the remaining ones. So 128 plus 64 plus 32. That makes 224. That's how you come up with the subnet mask over there. That's the easiest explanation that I can come up with. Yes, there will be a wastage of IP address, I would say. But over here, we just need 30 hosts per network. Correct? That's why the combination just matches up correctly. Cool. Someone is saying that slash 27 is not the case. As if that's the case, we only have 32 hosts, but we need 32 multiplied by 8 hosts at max. Yes, that's correct. If you need more networks and if you need more hosts, then you switch the class from class A to class B. We will be talking about that sooner. Now over here, we are making 8 different networks. You can see. And for each network, we have 32 hosts. Out of that, the usable host will be 32 minus 2. That will be 30 hosts. So not a single IP address is going to be wasted. But it can be a case where IP address can be wasted. Cool. So I hope you understand how we came up with the subnet mask. And now let's talk about the block size. So the block size is going to start from 192.168.1.0, and the first one is going to end up at 192.168.1.31. You just need to add the number of hosts that you have. Cool. The second network is going to start from 192.168.1.32, and it's going to end up at 192.168.1.63. The third network will be over here 192.168.1.64 to 192.168.1.95. The fourth network will be 192.168.1.96, and it will end up at 192.168.1.127. Okay, the next network will start at 192.168.1.128 to 192.168.1.159, 192.168.1.160 to 192.168.1.191. Then you go up with 192.168.1.192 to 192.168.1.223, and then you end up with 192.168.1.224 to 192.168.1.255. So you see, block size is nothing but number of networks that you can use. We specified over here that you are going to have 8 networks, and for each network you are going to have 32 hosts. So the first network that was going to be started, because we took 192.168.1.0/24 as our major network, that gave us 255 IP addresses, and we divided it into multiple small parts. And those small parts, how many parts were made? 8 parts were made of this major network, and each part had 32 IP addresses. So the IP address will start at 1.0, of course, and we will add 32 IP addresses in each and every network over here. So the first one starts at 1.0 and it ends up at 1.31. The second one starts at 32 and ends up at 63. Okay, then the next starts at 64 and ends up at 95. We just keep adding 32, 32, and we increase it and we reach out to 255. And that's 1, 2, 3, 4, 5, 6, 7, and 8 networks. Each network is having 32 IP addresses, out of which 30 IP addresses are usable, as out of each, I would say, network, the first IP address is network ID and the last IP address is broadcast ID. Okay, this is again network ID, this is broadcast, this is network, this is broadcast. Okay, so all these addresses are network ID and all these addresses are broadcast ID. Do you understand that? I hope it makes sense now. You cannot add more devices to network number 1. It will automatically go to network number 2. Yes. The valid IP address from the first network will be from 1.1 to 1.30. From second network, it will be 1.30 to 62. Sorry, 33 to 62. From third network, it will be 65 to 94. Like that. Subnetting is a must in real life scenario. Yes. The network ID basically is the first IP address. First IP of each network is equal to network ID, and last IP of each network is equal to broadcast ID. Yeah, we will. I'll clear about the borrowing and all again. Don't worry. When you have a requirement that goes with 5 network with 40 hosts, then this is not a requirement that you should come up with. Okay, instead of using like, so when you have like a network requirement that says 5 networks with 40 hosts, okay, then your network admin will provide you 2 major subnets that says 192.168.1.0/24, and you will also get 192.168.2.0/24. You get that? So you will divide this 256 divided by, what's the bigger value than 40 over here? That's 64, correct? So you divide it by 256 by 64 and the answer will be 4. So you will put up 4 networks only from this subnet or from this major network, and the fifth network will be given from another major subnet. Make sense? I guess the doubt was asked by Sachin. Cool. We will take another example. Okay. So now, as we were talking about what will happen to these 5 networks, okay, only 5 networks and 30 hosts needs to be used. So we will only use the 1, 2, 3, 4, and 5. Only networks, these networks would be used, and rest of the other networks will be reserved for future purposes. Whenever there is a network, then I would say that the future networks will use the remaining 3 networks from here. Okay, they are not wasted. You can still use it. Cool. So let's have another example of /25, let's say, and we will see how it goes. Well, Amrita, you cannot really go directly with like 40 IP addresses straight away, because the networks are designed in power of 2. Yes, we are going to take one more example. I was just answering some of the questions into the chat. Oh, we're going to discuss about /22 tomorrow. Today we will just talk about class C. Okay, let's take another example of 192. Network ID is basically used for the purposes when you implement routing, and so we will talk about that. Okay, it's just assume it as it's reserved for some purposes. You will know about the purposes later in this particular course. So we are going to take 192.168.1.0/25. I will also write down the master formula that we have been using: 128, 64, 32, 16, 8, 4, 2, and 1. Cool. And then we are going to, let's say, we'll convert this /25 into binary. That is 11111111, and when we borrowed this 1, correct, and then rest of them are host prefixes. Do you understand that this is the one that has been borrowed at the 25th location, and these are all network prefixes, and these are all host prefixes, and that's the network prefix that has been borrowed. Makes sense? Any questions still here? Is it all clear? How did we come up with /25 and its binary value? So we again come up to the formula. The first thing is number of network, and again the number of network is going to be 2 to the power 1, because 1 is the borrowed bit that is over here. That gives you 2 networks. Cool. The second value is going to be number of hosts. Cool. And the number of hosts is going to be 2 to the power 7, because these are the number of zeros that you have. Make sense? And that's going to be 128. Any questions still here? Do you understand how did you come up with number of network and number of hosts? Cool. Then third, we talk about how did we come up with subnet mask. So subnet mask, we just write down the binary, the dotted decimal value of the subnet mask over here. That is 255.255.255. 8 bits, 8 bits, and 8 bits. And then you just have this 1 bit over here, which can be compared with this 1 bit of the master formula that is available. That's 128. So we say 128 over here. That's how you come up with the subnet mask. Okay, that's 255, 255, 255, 128. That's going to be the subnet mask for /25. Cool. And the fourth thing is the ranges or block size. Now the usable IP address is going to be 128 minus 2. That's 126. Correct? The valid host is 126. And the block size again starts at 192.168.1.0 and it ends up at 192.168.1.127. Cool. And the second network will be 192.168.1.128 and it ends up at 192.168.1.255. You see that 128 hosts over here and another 128 host over here. 128 plus 128, that's 256. That's the total value that you get. So we just had two networks and each network had 128 hosts here. Do you understand now how do we come up with subnetting? The network ID over here is 1.0 and 128. The broadcast ID is 127 and 255. So the usable IP address would be for first network that will be 1.1 to 1.126. The second network will have usable IP as 1.129 to 1.254. Are we good here? Yeah, subnet mask basically is nothing but the dotted decimal conversion of this number of on bits. So whenever you say, uh, whenever you come up with the binary value, let's say /25, then you just write down 25 ones, correct? 1 1 1 1 1 1 1 1. Can you figure out what this binary value is going? Sorry, binary value is going to be in the dotted decimal? Let's consider our master formula, that is 128 64 32 60 16 8 4 2 and 1. So you write down this 8 ones as 1 1 1 1 1 1 1 and 1. And if you add them all together, that's going to be 255. So for the second octet, everything is again going to be 1. So that's again another 255. The third octet also has, that's another 255. And then last octet, you just have one bit that is borrowed, and rest of them are all 0. So the binary comparison over here becomes like 1, sorry, becomes like 1 0 0 0 0 0 0 0. So that's 1 is just 128. So you specify 128 over here. That's how you come up with the subnet mask. It's easy. When you remember how do you actually use the master formula, it's easy peasy. Broadcast ID is used to broadcast message in a, yes, it's correct. Whenever you want to send a message to everyone that is present into the network, you can just send that particular thing on these addresses. Okay, on the broadcast addresses. Well, we will talk about how do you figure that out. We still need another class in subnetting. It cannot be done in just one all. And it's all decided by INA. Yeah, I can say that it's all decided by INA and IETF in collaboration. Well, IPv4 and v6 has their own differences, so it's not a good idea to compare them right now. Just give yourself some time because you are still in eggs, I would say, and your eggs needs to be broken out. And yeah, you just need to grasp some decent experience as of now in subnetting. The only thing I would request all of you is to keep on practicing on subnetting. Okay, you cannot just leave subnetting like that. You need to always be in practice of subnetting to be able to subnet a better production network. We will talk about how to sending messages and all. We haven't started our labs yet. Don't worry about them. There will always be some IP addresses that will be wasted. Okay, you cannot ever design a network that doesn't waste any single IP address. ISP does not pay to INA directly. They pay to, I would say, for public IP addresses, ISPs do pay. Yeah. So if requirement is 90 host, and the number of hosts will be 2 to the power 7. Yes, that's correct. Well, concerning the waste of IP addresses, earlier we used to directly use networks like 1.0, okay, 2.0, 3.0, 4.0. Over here, we are just using this one network and dividing it into different parts. We are not going to use 2, 3, 4 or so. So those 2, 3, 4 can further be divided and your infrastructure can be better planned over there. Makes sense? So, Therese, Class C IP address is reserved for future and research purposes. It's not a waste. It's better planning. Yes, we are. I'm giving you the homework and all. Just wait for that. Dinesh, there is no trick. I would say this is the best formula that you can use. I've been doing this stuff since last 7 to 8 years, so I don't even need a paper to do subnetting. It's I can do it in the air. Just practice makes you perfect over here, or practice would make you perfect at anything. I would say. Slash 25 indicates that what the subnet mask that is going to be used. It's just a short form of the subnet mask. Subnet mask is actually a value with which the router can decide that what's the range of the network that you are using and what's the network ID, what's the broadcast ID. It can figure out anything regarding a network by just considering the subnet mask. Yes, that's correct, Wakar. We'll talk about the loopback and all those interfaces later while we will be discussing about labs. Don't worry about that now. We'll talk about VLSM in 2 or 3 more classes. Yeah, we're coming up with VLSM and FLSM and all. Don't worry. These are all concepts that are coming up. Don't worry about them. Just focus on what we are covering. You can trust on me that I'm going to cover each and everything that is important in this particular course. So don't just hurry up, otherwise, it will not make sense to you. Like I say, make sense. So I'll just give you some homework that you can do for me, okay, or some assignment. What you need to do is you need to practice on paper with the same network, that's 192.168.1.0, and you need to do subnetting for slash 25 slash 26 slash 27 28 29 and 30. Okay, you need to practice this. Examples of tier 1, tier 2, tier 3 ISP, you can google them, man. That's pretty easy. It depends on your geographical location as well. Tier 1 is international ISP, Tier 2 is national ISP, and Tier 3 is local ISP. International ISP is AT&T, Tier 2 is Airtel, let's say, and Tier 3 can be, I would say, Nextra or Triple Play or some local ISPs, Spectra, like that. Yeah. They kind of rent out the bandwidth from Airtel and then you give it to their own customers. That's how it works. Anyways, these are the subnettings that you need to do, okay? And that was all about today's class that we had to discuss. In tomorrow's class, we'll be discussing about Class B addresses and Class A subnetting. Okay, and we will see how it goes there. That's going to be our tomorrow's agenda. So thank you so very much for tuning in today. Okay, I hope you enjoyed the class today, and we talked about subnetting in a very neat and clean manner to the most I could. So I hope you enjoyed the class. I'll see you guys tomorrow on the same time. Till then, thank you so much for joining. I wish you all a great day ahead. So, yesterday we did talk about subnetting, in which we saw how we can subnet to different networks when we have 1.0 network with a slash 24. You can say that we can use some of the formulas that we have. The first formula can be number of networks, and that can say that if we convert it into binary. Now, those who didn't understand subnetting yesterday, they can also pay attention while I'm reviewing the Class C subnetting standards over here. So the first step is for you to understand that how you can convert the CIDR value into binary value. So as you have the CIDR mentioned as slash 24, you can write down the binary value of it as you have 24 ones. These are our 8s. I'll separate them with a dot. These are another 8s. And then these are the last 8s that you have. And then you will see 0, 0, 0, 0, 0, 0, 0, 0. So you can say that the range that you have, this one is for network prefix. And then you can say this one is for host prefix. Correct? Now this is default scheme. We haven't divided anything from the host prefixes. So whenever we kind of convert I would say the bits from host octet to network prefix, then we say that these bits would be assumed as borrowed bits. Otherwise, they will not be considered as borrowed bits so far, because they are still there and we are just using the default scheme that is available there. Also, let's say that we haven't borrowed anything, and what's going to be number of network over here? It's going to be 2 to the power 0, because number of network is nothing but 2 to the power number of borrowed bits, which means the bits that have been converted from host bits to network bits. I hope my voice is clear and loud. And then this would be 2 to the power 0. That gives you an answer as 120. That gives you an answer as 0. 1 itself. 2 to the power 0 is 1. And then you figure out the second thing, that is number of hosts. And you can say number of hosts is going to be how many bits do you have as 0? And these are 8 bits. Correct? So you can say 2 to the power number of bits. And that's going to be 2 to the power 8. And you get 256 as the answer. Correct? And as we start our IP address with 0, we are going to end up at 255. But the number of usable, or I would say valid host, is always going to be 256 minus 2. And this 256 is nothing but number of hosts. So you need to figure that out. And then the third part is going to be subnet mask. And subnet mask, we just figure that subnet mask out by just converting the number of on bits, or I would say the CIDR value, into dotted decimal. Cool. So it's going to be 255.255.255.0. Correct. So this makes our first 8 bits. The second octet provides our second octet or second 8 bits, and the third octet provides the third 8 bits, and the last 0 represents the last 8 zeros that you have. Then the fourth range is going to be figured out for block size, or we can call it as the ranges. So you can say that the ranges are going to, of course, start from 1.0, where the first network is going to start at 192.168.1.0, and it will go till 192.168.1.255. Do you understand that? So that's exactly because we need 256 IP address in one network. So we start at 1.0 and we end up at 1.255. Since we start at 0, we end up at 255 and cannot go till 256. Perfect. So that's slash 24 at our end. Okay. And then I hope it's cool and clear. Then we will just try and do slash 25 just beneath it, so that it's easy for you to compare both the subnets and see what the differences are. So let's say we go 192.168.1.0 slash 25. This is what we are seeing. And if we compare the slash 25 into binary, it's gonna be, these are going to be our 24 bits. And then out of, I would say, the last 8 bits, that is, these are our host prefixes, right? We are going to borrow 1 bit for the 25th bit that you see over here for slash 25. So what we are going to do, we are going to convert the first 0 of the last octet into 1, correct? And remaining 7 are going to be the part of host prefix. So you can say that this is still host, and then this is network, and this bit acts as our borrowed bits. Do you understand that? So when we again come up with number of, I would say, network, then we specify the 2 to the power number of on bit, that's 1. which is this bit. Then the answer is 2 over there. Then for second, we specify what is going to be the value for host, and that's 2 to the power 7, correct? Because we have 7 zeros over here, and that gives us 128. So you see how the division is done over here? Totally in class C, you are just going to have a network of 256 each time you do any kind of subnetting. You cannot have a network that is bigger than 256 in class C. So, like whatsoever you do with the subnetting, the network is just going to be divided by some value that would be in the power of 2, okay, to get some smaller part of the network. So earlier we had a big network of 256. Then we are dividing it into 2. Okay, so we make parts of 256 divided by number of network, that is 2. And that gives us 128, correct? So we make two networks of 128 hosts. If we divide it by 4, you're gonna get a 4 network of 64 hosts. That's how it works in class C. Okay, and as the value of CIDR changes, the things changes as well. So currently we are going to get two networks, okay, and then we are going to get 128 hosts in each of that particular network. Makes sense? And out of which the valid host is equal to 126, sorry, 126. And the third thing that you need to figure out is subnet mask. And subnet mask is going to be the dotted decimal conversion of this value, which is 255 for the first octet, dot 255 for the second octet, dot 255 for the third octet. And then as you have this one bit on, you need to consider the master formula that we use: 128, 64, 32, 16, 8, 4, 2, and 1. Out of this, there is just first bit that is on, which is this. If it is 11000000, then first two bits. So you compare 128 plus 64. If it's 3 bits on, then you take the first three values of your, I would say, master formula. But as there is just one bit that is on currently, we are just going to consider that, and the last part will come up as 128. That's how the subnet will come up. And then the fourth thing will be block size. And block size is going to be 192. The first network is going to start at 192.168.1.0 and is going to end up at 192.168.1.127, because we are going to have 128 hosts in each network. So we start at 0 and end up at 127. And then the second network is going to start at 192.168.1.128 and it's going to end up at 192.168.1.255. This is our network number 1. That's our network number 2. The first IP address are going to be network ID, and the last IP address are going to be broadcast ID. Make sense to you? Any questions over here? This is the easiest way that you do subnetting with. Subnet mask will be same for all the networks that you use. Which binary number are you talking about, Shri Lakshmi? This is basically the binary number, or I would say the borrowed bit that we have borrowed as part of the host and made it as a network bit. So that's why we'll call it as binary bit or borrowed bit. Valid host count differs on the type of subnetting that you're doing. If it's /25, then the value of course will change. But you just need to mention that the number of hosts will keep on changing as you keep on changing the subnet. Okay, so the valid host is always going to be number of hosts minus 2. That's not a host ID, that's going to be a network ID. We just split it by doing subnetting over here. Okay, you will understand how do we configure the subnetting when we will do the lab. Cool. Then we will move ahead with the next part, and we will try to also see how /26 and /27 works, so that you can understand and get more familiar with it. So we will move ahead with 192.168.1.0/26. Okay, the things that we need to focus are network, then you need to figure out host, then you need to figure out subnet mask, and then you need to figure out block size. Cool. So these are the things that you need to do. Again, following the drill, what do we need? What do we do at the first time? We write down the master formula, that is 128, 64, 32, 16, 8, 4, 2, and 1. This is your master formula. Then you convert this slash 26 into binary bits. That's going to be 11111111. This is 16. This is 24. And then you borrow 2 bits from the host. That makes it 26. And then you write down the remaining 6 bits as the host. Okay, and these two are going to be network, which is going to be borrowed. Cool. So the number of network becomes 2 to the power 2 over here. That gives you 4 networks. And the host becomes 2 to the power 6, which are these. That becomes 64 hosts. And the valid is equal to 62. Correct? Then the subnet mask for this becomes 255.255.255 dot. It's going to be first 2 bit. That means 128 plus 64. Okay, that gets 192. And the block size are going to be 4 different networks. So the first network starts at 192.168.1.0 and it ends up at 192.168.1.63. The second network starts at 192.168.1.64 and it ends up at 192.168.1.127. The third network starts at 192.168.1.128 and it ends up at 192.168.1.159. The fourth one starts at 192.168 dot. Okay, this is kind of a wrong value that I have mentioned. It ends up at 191. Cool. Adding 64 into 128. And then the next one will start at 192 and it will end up at 192.168.1.255. These will be your 4 networks. Okay, that's how you work with slash 26. Moving ahead, we will move with slash 27. And let's say that's 192.168.1.0 slash 27, and in which we will figure out the binary is going to be this is the last example from class C that we're going to have, and then we will say our 3 bits will be borrowed 25, 26, 27, and then 28, 29, 30, 31, 32. So I will write them as cool. These are going to be host and these are going to be network. So the first thing that you figure out is network. The second thing is going to be hosts. The third thing is going to be subnet mask. And the fourth thing is going to be ranges or block size, whatever you call them. The number of network is going to be 2 to the power 3 over here because of the 3 bits that you have, that makes it 8. The host is going to be 2 to the power 5, that makes it 32. The subnet mask is 2 to the power 255, 255, 255, 3 bits. That means 128, 64, and 32. That makes it 224. And the ranges are from 1.0 to 1.31, 1.32 to 1.63, 1.64 to 1.95, 1.96 to 1.127. That's how you come up with the first 4 networks. The second 4 network would be 1.128 to 1.159, 1.160 to 1.191, 1.192 to 1.223, 1.224 to 1.255. That's what the thing was. All these would be network IDs and all these would be broadcast IDs. Do you understand that? That's how you come up with the slash 27 subnet. Okay, so I hope you understand the subnetting. Now there is this one catch that you need to understand. Whenever you kind of see a slash 31 network and slash 32 network, we don't really use them in class C subnetting, because if we go with 192.168.1.0 slash 31, what you will get is, if you convert it into binary, 1 2 3 4 5 6 7 8 9 10, 8.1111111, 1 2 3 4 5 6, and then you get 0 0. So when you have only, sorry, you don't get 0 0, you get 1 and only 1 0. So what you have over here is just one bit off for host. So that makes number of network is 2 to the power 7, which is 128, and number of host becomes 2 to the power 1, which is just 2. So you can see that the valid host cannot be in, as one is going to be network ID and the other one is going to be broadcast ID. So that's why we don't really use, I would say, slash 31. And in 32 as well, there won't be any bit that would be reserved for number of hosts. So it's going to be just one IP address that will be used. So that's why we don't use slash 31 and 32. And we only use till slash 30. In slash 30, what you get is 2 to the power 6 as number of hosts. That gives you, sorry, number of network. And as host, you get 2 to the power 2 as 4 IP address, and valid IPs would be 2. And where will you use these two? Whenever you connect a router with another router, you can use this one IP address on this end and the other one as this end. So they both can talk with each other and communicate with each other by staying into the same network. That's why we call it as point to point subnet. Sense, we call it as point to point subnet over here. So that's what the content was for slash 30. And then we will go into class B subnetting now. In class B subnetting, the range will be from slash 16 to slash 23. And let's say that we take an IP address of class B, that is 172.16.0.0, and we do subnetting for slash 23. So what do we do for the first time? We just write down the binary scheme and also the master formula that we use. Correct? So it's a 11111111. That's 8 bits. That's 16 bits. And this is default N and default N. And what are we going to do? As it has all like the 16 bits reserved for, it is determined based on the network prefixes that are allocated. Okay, if we talk about class A has a network prefix of N, 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 and H. Sorry, class A has a network prefix of N, H, H, and H. Class B has N, N, H, H. So 2 octets for network and 2 octets for host. That means that slash 16 is always going to be dedicated, okay, for network. And how much you can do modify in it? You can go and turn on all the bits of, or I would say less than 1 bit of third octet. So that goes till slash 23. As soon as it becomes slash 24, you are jumping into class C. That's why we have said that class B has a range of slash 16 to slash 23. Cool. And if we specify the host prefixes that you have, those are going to be 0 0 0 0 0 0 0 0. You understand that? This is going to be network. This is again going to be network. Then this is going to be host, and this is also going to be host. Cool. Now what's happening over here in slash 23? We are borrowing the first 7 bits that we have. So the first 7 bits are going to be these. right? And we are turning them on with 1 1 1 1 1 1 1. Correct? So instead of having all the 8 bits dedicated for host portion, you just have now this, I would say you just have now this particular bit as host, and it has been converted. The first 7 bits has been converted into network, and we will call these 7 bits as borrowed. So when we talk about the formula that we have, we talk about the formula that is for network, we specify 2 to the power 7, correct? Because these are the 7 bits that are on. And then the answer is 128 networks. Cool. Then for hosts, we specify a number of off bits. How many bits are going to be off over here? You can just connect to single router with multiple networks. That's fine. How many host bits are here? It's not just one. It's collection of all these bits. That's 8 bits, 1 bit from the third octet and 8 bits from the last octet. That makes it 9. So that's why the number of hosts is going to have a value as 512, because 2 to the power 9 is 512. It means that you are going to have 128 networks, and in each network you are going to have 512 IP address, out of which usable will be 510. Now pay your attention, as class B, understanding this part of subnetting is very crucial. Okay, so do you understand how did we come up with number of network and number of host? Any question till here? Cool. I'll clear that again. So again, we will talk about how did we come up with this information, because understanding class B is pretty crucial. So you all agree that we are talking about class B network, right? That's why we have taken slash 23 as the example. So if I write down about slash 23, I can say that it's 1 1 1 1 1 1 1, because class B has a network prefix of N and H, and H means two octets are dedicated for network and 2 octet for host. That's why I'll write the 2 octet as 1111 in black. It means that we cannot do anything over here. Cool. So I'll say 1 1 1 1 1 1 1 1 and another set of 1. So this is all reserved for default network prefix. Then by default, we have everything dedicated for host. So the first 8 bits and the last 8 bits. These are the host and these are the host. What do we do is, as we need slash 23 over here, we just specify the first 16 bits and then we add plus 7 bits from the host portion. And that's how we come up with the slash 23 binary value. So the value will now change and it will remove the first 7 bits, okay, from the third octet, and it will add its own 7 bits. Do you understand that? And then the last bit will be the 0 and then dot and then everything will be 0. So this is staying the same. You just got one off bit over here. And then the remaining thing that is over here is going to be n. And this n is nothing but borrowed from host. That's why we say number of networks is equal to 2 to the power 7. That says 128 network. Now talking about host, host is nothing but all the off bits that you have in your binary conversion. So how many bits do you have in subnetting? You have, subnet mask is made up of 32 bits, right? Minus how many bits did you dedicate to the network prefix? 23, correct? How many bits are left? 9. These 9 bits will be what? Hosts. This is as simple as that. So then you specify these 9 bits as number of hosts, that says 2 to the power 9, and you get a value of 512. Do you understand that now? Perfect. All right. Then we will move ahead towards figuring out the subnet mask. And the subnet mask is going to be the dotted decimal conversion of this binary value. That's how many bits do you have? 23, correct? So for the first 8 bits, it's going to be 255. For the second 8 bits, it's going to be 255. For the third octet, now how many bits are these? 8 plus 8. How many bits do you need? 7. So you need to put down the 7 bits into the master formula, which would be the addition of these. Okay, and the addition of these would be 254. Cool. Do you understand that? It will be the addition of 128, 64, 32, 16, 8, 4, 2, and 8, 4, and 2. And the addition of this will be 254. I hope you understand that. That's how you come up with 254, and then the last octet will be 0. Any question till here in the subnet mask? Perfect. Now we will move ahead to the most important part of class B subnetting, is figuring out how block size would be made. Okay, so the block size will of course start at 172.16.0.0. Cool. And this is N, this is N, this is H, and this is H. So we can play and make changes into last two octets. If we talk about this address, which is 192.168.1.0, the first, second, and third is N. That's why we can only make changes into the last octet. But in class B, you can make changes into the third octet and fourth octet as well, as they belong to the host prefix. So we will start at 192.172.16.0.0, and where would we end? We would end up at 172.16.0.255. Correct? That's how we usually end. Make sense? And how many IP addresses are these? 256 IP addresses. And what would be the second network? The second network will start with 172.160, sorry, 172.16. And then we can make changes to the third octet. So as 0 is complete, okay, we took down everything from 0. So from 0.0 to 0.255 we are done. Now the third octet will change to 1.0 to 172.16.1.255. Have you seen your meter, or I would say kilometer reading in your, or miles reading in your car, right? The speedometer. It says by default when you purchase it, it shows 0.00000. Correct? And then it as you drive your car, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this value becomes 1, and then this particular thing again repeats, and then you will see 2 over here, and then second iteration and 3 over here, third iteration 4 over here. So this is how it becomes 11, 12, 13, and then 21, 22, 23, and then 31, 32, 33, right? So as the last octet fills it up, then the changes happen at the third octet, or the second last octet, I would say. Just like that, over here as well, if you can relate to it, the third octet got filled. It cannot go to like 200 and like can we say that instead of writing it like this, can, as we need 512 IP address in one network, can we write it like 172.16.0.0 to 172.16.0.511? Can we write it like this? We cannot write it like this, right? Because the maximum value that we can have in an octet can only be 255. So that's what we are saying. We will write down the last value as 255. And then this is just 256 IP address. But what we need another 256 IP address. So what we do, we say the next network is 172.16.0.0. Okay, but we cannot start with 0.0 again. We gotta start with 1.0 now, and then we're gonna end up at 172.16.1.255. And what is this? This is another 256 IP address. So you can say that You got these 256 and you got these 256. When you put them together or add them together, what's going to be the output? 512. Do you understand what I just did mention over here? We've got this first network and we've got this second network, and each network gives you 256 IP address. If we merge those two segments of 256 IP addresses together, can we get an entire block of 512 IP addresses? Do you agree with me? Yes, Dinesh, that's what I'm saying. That we need 512 IP addresses. So if we take a network of 256 IP addresses, which is 0.0 and ends up at 0.255, and then we take another network of 256 IP address, and that will again be another 256 IP. So, and if we merge, or I would say make these two networks or two segments as one network, okay, will it be possible that this can become a network? Because see, I can say that we start at 0.0 and we end up at 1.255. So we are kind of merging two different segments of 256 IP addresses and merging them into one. So we can say that the first network starts at 172.16.0.0 and it ends up at 172.16.1.255. Do you understand that? How many network bits do we have? We have two network bits, that is this and that is this, that is this and this. Did we make any change into this? We didn't change either 172, we didn't change either 16. Both the octets are same. That's why people can communicate when both the octets are same over there. Do you understand this particular logic? Take some time to digest it and let me know. Perfect, perfect. So what we do over here is whenever the number of hosts crosses its limits and it becomes 512, we need to merge different segments, okay, of 256 and add it. That's what we do. And then this will be the first network of the 128 networks that you have got. So what will be the second network? The second network will be another merger of another two segments of 256 IPs. So it starts at 172.160, sorry, 16.2.0 now, because 0.0 and 1.0 are both of them are used. And then we start at 2.0 and we end up at 172.16.3.255. Another two segments are merged over here. Do you understand that? And the third segment would be 172.16.4.0, and we will end up at 172.16.5.255. That's what the thing is. So in each network, you've got 512 IP address, 512 IP address, and 512 IP address. And you are going to have 128 such networks, okay, each having 512 IP address. So you can imagine how bigger of a network that can make. That's why we say class C is used for smaller networks, class B is used for medium sized network, and class A is used for larger size networks. Do you understand that? Now there is just one logic that you need to understand over here, that we are saying that how many segments do we actually merge? How do you get to know that? Okay, because over here it's easy to calculate that 256 and 256 makes 512. But let's say you got to figure out that for a 16,386 host size, how many segments do you merge? So for that there is a logic. Now do you understood how did this slash 23 work? I can explain you that logic in slash 22. Both the IP would be different. Yes, both the IPs would be of different network, meaning that this network cannot talk with the other network. That's not possible. But people, these 512 people or 510 people who are connected there can communicate together. Okay? And what's going to happen? This is going to be your network ID now. and this is going to be your broadcast ID for the third network. Cool. If we say that in this network we merge two networks, right? 172.16.4.0 and it ends up at 172.16.4.255. And then we again merge 172.16.5.0 and 172.16.5.255. Earlier, this also was network ID and this also was network ID. And this was broadcast and this was broadcast in class C. But now, if we just talk about current scenario, only 4.0 is network ID and only 5.255 is broadcast ID. The 4.255 and 5.0 will be normal IP addresses and they will be usable and they can be assigned to any, I would say, host there. So that's what needs to be considered over here. Are we good? Do you understand this slash 23 example? Yeah, we'll talk about subnet mask again in next example. Don't worry. No, we cannot use network ID and broadcast ID in any network device. They are used, however, for specific, I would say, concerns for configuring DHCP and so on. So we will talk about that later as we move ahead. All right. So let's keep this example over here and move with the next example in which we can see that how would it get clearer even more. So the next example that we can take is 172.16.0.0 and let's do it for slash 22. We will just see how this can be done for slash 22 and we will first convert it into binary as the drill continues and we'll say 1111111 and over here we are going to have 16 plus 8 that makes 24, so we don't need 8 bits. 16 plus 6 makes 22, so we need to borrow 6 bits, correct? So we'll say 1 2 3 4 5 6 and then we will add the remaining 2 to complete the octet and then we have another 8 bits as the host and this continues to be network. Good. We specify the master formula over here as well. 128 64 32 16 8 4 2 and 1, and that gives us that. Let's configure number of network, that is going to be 2 to the power 6 as 6 are the number of borrowed bits and we say 64, and the number of host is going to be 2 to the power 10 now because you have 2 plus 8, correct? This it's going to be 10 and then you say 2 to the power 10 is 1024 and then you specify subnet mask is going to be something like 255.255 dot. How many bits do you need to add now? 6 bits. So we say 128, 64, 32, 16, 8 and 4. That basically makes it as 252 and then we say dot 0. If you add the first 6 bits from the master formula, it's going to be 252. Do you understand that? And then talking about the block size, we start at 172.16.0.0 of course, but now how many segments of 254 needs to be merged? So we say now there is a logic that whenever the number of hosts gives you a value that is greater than 256, understand this logic pretty well. Whenever the number of hosts is greater than 256, divide it by 256 in order to fetch out the number of segments that you need to merge. So if I divide it by 256, you get an answer of 4. That means 4 segments need to be merged, which means if you start at 0, then 0, 1, 2, and 3. These would be the 4 segments. So what it means that if we start at 0.0, we end up at 172.16.0.255. That will be the first segment. The second segment is going to be 1.0 to 172.16.1.255. The third segment is going to be 172.16.2.0 to 172.16.2.255. The third one is going to be 172.16.3.0 to 172.16.3.255. Correct? These are going to be 1, 2, 3, and 4 segments. So this one becomes our network ID and this one becomes our broadcast ID. And totally combine them, these are 1024 IP address, as 256 multiplied by 4 is 1024. Do you understand that? So the first network for this particular thing, for this block size, is going to be 172.16.0.0, and it's going to end up at 172.16.3.255. The next network, the second network out of the 64 networks that you're gonna have, is 172.16.4.0, and it's gonna end up at 172.16.7.255. Do you understand that? Perfect. The third network is going to be 172.16.8.0, and it's gonna end up at 172.16.11.255, and you will have the 64th network will look like 172.16.252.0, and it will end up at 172.16.255.255. That's what the last network will look like. These will be 64 networks and 1024 hosts per network, out of which 1022 will be usable. I hope you understand that thing. Perfect. So that's kind of an example that we can take for class B. The last part is the IP address. I would say the 64th network. So it's gonna be like just like that. You're gonna have 64 networks, and the 64th network will start from 172.16.252.0, correct? And then it's gonna end at 172.16.255.255. Cool. And you're gonna have 64 networks like that, and 1024 hosts per network, out of which 1022 will be usable. I hope you understand these two examples of class B. Now, supernetting is not really used over here. Okay, supernetting is some other concept, so don't focus on that as of now. We are doing subnetting and not supernetting. All right, that wraps our first section of the class. Let's have a break for 10 to 15 minutes, and then we will resume with the second section, in which we will talk about more examples. Okay, and then we will move to class. And then we will move to class A subnetting. So you can practice at home for 172.16.0.0 slash 21, okay, slash 20 slash 19 slash 18 slash 17. These are going to be your homework, I would say. And then we are moving ahead towards class A subnetting. Cool. And in this particular class A subnetting, we're going to take an IP, and the range for that is going to be /8 to /15. So makes sense that we'll be making the modification into second octet over here. So we will talk about an IP address or a network that would be from class A, that's 10.0.0.0, and then we will do the subnetting for /15. Cool. So we got to figure out first thing as number of network. The second thing is going to be number of hosts. The third thing would be subnet mask as always. And the fourth thing is going to be ranges, or you would say block size of that. So as the drill continues, the first thing is we write down the /15 parameter into binary. So we say 1 1 1 1 1 1 1. That first 8 bits are going to be about network, as class A uses a scheme of NHHH. So you get 24 bits as hosts, okay, and 8 bits as networks. So these 8 bits are going to be dedicated for network, and then we will move ahead and say the next 7 bits are going to be dedicated as borrowed network bits, and then there will be a last bit that would be 0 from the second octet, and then everything apart from that will be 0. Do you understand that? Any questions here? Just like we saw in class B, you would have a default network range that is going to be this. Then you are going to have the borrowed bits. These are going to be the 7 borrowed bits. As you are working with /15, The breakup of slash 15 works like slash 8, which is going to be default, and we will borrow slash 7 as I would say borrowed. That's how we come up with slash 15. Okay, so these 8 bits are going to be our default bits, and these 7 bits are going to be our borrowed bits, as we are going to have default schema of H. The last 3 octets are going to be host prefix. Makes sense? So that's why we're going to have the first 7 bits as borrowed bits and the remaining bits as the host bits. So moving further with that, how are we going to have our number of network? The number of network would be 2 to the power 7. That's 128 again. Then for number of host, you can say how many hosts do we have now over here? How many bits do we have dedicated for host? We have this 8 bits, we have the last 8 bits, that makes it 16, and plus this 1 bit from the second octet, that's 17. So we say 2 to the power 17 as number of hosts. And what's the value of 2 to the power 17? It's 131,072. That's what 2 to the power 17 makes. You can Google it or you can use your calculator. Cool. It's 131,072. And then how do we come up with subnet mask? It's going to be 255 dot. These are the 8 bits. Plus we need to add 7 bits from the master formula that we have. That's 128, 64, 32, 16, 8, 4, 2, and 1. That's going to be first, I would say 7 bit again makes it 252. So we'll say 254.0.0. The first 7 bits and adding them together makes it 254. So that's what the subnet mask will be. Okay. And then talking about ranges, it's going to start at 10.0.0.0. And how many, again, we need to merge certain segments over here. And the modification is going to be done over here, not on the third octet anymore. So when you do modification, so when you do class C subnetting, the modification is done at last octet. When you do class B subnetting, the modification is done at the third octet. And when you do modification at, when you do subnetting for class A, you do modification at second octet. That's how it works over here. Cool. So I say 10.0.0.0. And then how many segments do we need to merge? We need to divide it by 256. And when you divide it by 256, the answer is still going to come as 512. Am I correct? If anyone is doing it through calculator. If I divide 131,072, which is 2 to the power 17, by 256, the answer comes at as 512. Now you see the value is still bigger than 256. And our rule is until unless you get a host value that is less than 256, just keep it dividing. So we will again divide this result with 256 and you will get an answer as 2. So as the division is happening for twice, that's why if no division is happening, this is where we make the changes. If division is happening for once, we shift it from last to third. And if division is happening for second, then we shift it 2 times. And we do the modifications over here on the second octet. Do you understand that? So we are going to start from 10.0.0.0 and we reach at 10.1.255.255. You see that? As we are dividing it for twice, okay, the change that the addition of the segment is going to affect at the second octet, 0 and 1. In class B, we only did make the change for once. That's why we made the changes at third octet. Okay, we used to say that 172.16.0.0 and then we stopped at 172.16.1.255. So this is where we made the change into the third octet. But over here, this is we just have one network prefix and everything is host, host, and host. So this is where we need to make the change on the third octet. Make sense? The next network out of this 128 networks will be starting at 10.2.0.0 and ending at 10.3.255.255. And then the next network will be 10.4.0.0 and 10.5.255.255. You get that? And in each network, you get 131,072 IP address, out of which 131,070 IP address are valid, because this will be the network ID and this will be the broadcast ID. You get that? Cool. So that's how you do class A subnetting. We will, yeah, what I said is just the first IP is going to be network ID and the last IP is going to be broadcast ID. Then we will have another example of class A subnetting. Let's say 10.0.0.0, or I would just write it in black and say 10.0.0.0 slash 14. Let's go for 14 now. And we'll just move it with by like writing the binary function. That's 1111111, and then 4 bits is 8 plus 6, that makes it 14, correct? So we add another 6 bits, that will be as borrowed bits, and the remaining 2 bits will be as host, and then we again have that acts as our. So this is going to be network, this is going to be borrowed, and that's going to be host, correct? And the master again 128 64 32 16 8 4 2 and 1. So the things that we got to figure out is number of network. The second thing that we got to figure out is number of host. The third thing that we got to figure out is subnet mask. And the fourth thing that we figure out is ranges. Cool. So the network is going to be 2 to the power 6, as we have 6 borrowed bits, and it's going to be 64. The host is going to be 2 to the power 18, and that can be, can anyone tell me what the value would be? 2 to the power 18, that's 262,144. The subnet mask is going to be 255 dot, we need to add 6 digits from the master, that's 128 64 32 16 8 and 4, and that makes an addition of 252.0.0. Cool. And then the ranges is going to start, of course, from 10.0.0.0. And how far are we going to go? We'll just divide this value with slash 256, and you will get a result of 1024. Cool. And as the value is still greater, we will again divide it by 256, and the answer will become 4. It means that we need to merge 4 segments together. And we start at 10.0.0.0 and we end at 10.0, 1, 2, and 3. These are going to be our 4 segments. So we end up at 10.3.255.255. That's the first network of our 64 networks. And then for the second network, we start at 10.4.0.0 and we end up at 10.7.255.255. For the third network, we start at 10.8.0.0 and we end up at 10.11.255.255. And for the very last network, for 64th network, we will start at 10.252.0.0 and we will end up at 10.255.255.255. Make sense? This, and this. Everything is going to be network ID. And this, and this. Everything is going to be broadcast ID. And every IP address between that is going to be a valid IP address that can be assigned to any host that gets connected over your internet. You understand that? That's how it exactly works. Yes, you have 64 network IDs and you have 64 broadcast IDs. Perfect. And then we can, so what you need to do for me is, for class B, you need to do from slash 20 sorry, from slash 17 to slash 21. You need to do this as homework. And for class A, you need to do slash 9 to slash 13. That's your homework. So these are the subnetting things that you need to do for me, okay, as part of your assignment. And then we are pretty good with subnetting.